morning, Algebra 1 CP students. This is a lesson for my B-Day students for May 21st and for my A-Day students for May 26th because we have Monday off. In this lesson, we continue factoring quadratic trinomials. So really, this is the only thing we're going to do for the rest of the year because, as I mentioned, the ability to graph lines and to factor quadratic trinomials are the two skills used the most from Algebra 1. So we're going to focus on this. Okay, so we're going to jump right to an example because we've already seen the basics of the steps. So factor quadratic trinomial x squared plus 4x minus 45. So what the answer is going to look like is going to look like two sets of parentheses, right? It's going to look like a FOIL problem. Something times something equals, when you FOIL it, is equal to this. Okay, so there are 7 steps. We'll go through them one by one. Step 1, if you think of this as ax squared plus bx plus c, we want to identify the coefficients a, b, and c. So a is the number multiplying x squared. Because there's nothing multiplying x squared, we know it's not 0, it's really 1. So 1 times x squared. So a is 1. B is the number multiplying x, which is plus 4 or just 4. And c is the constant term, c for constant. So c is negative 45. These coefficients are signed, meaning the sign gets included here. Okay, so that's all for step 1. A is 1, B is 4, C is negative 45. Sorry, if you were thinking it, you were correct before I wrote out the answers. Okay, step 2. You want to find two numbers, R and Q, that have this special property. When you multiply them, R times Q, you get whatever A times C is. And when you add them, you get whatever B is. Okay, so we're looking for two numbers so that there's product, or when you multiply them, well, what is A times C? A is 1, C is negative 45, so A times C is negative 45. So we're looking for two numbers whose product, or when you multiply them, you get negative 45, and their sum, or when you add them, you get 4. Okay, so they're called R and Q, but you can call them whatever you want. Okay, so I'm going to pause here. Can you think of two numbers that when you multiply them, you get negative 45, and when you add them, you get 4? Well, when you multiply two numbers and you get a negative number, it means one of the numbers is positive and one of the numbers is negative. So if you think of 9 and 5, right? Negative 9 times 5 is negative 45, and positive 9 times negative 5 is negative 45 as well. But you need the signs to be in a way so that when you add them, you get 4. So if you do a little guess and check, trial and error, you get that one of the numbers is negative 5, another of the numbers is 9. Negative 5 times 9 is negative 45. Negative 5 plus 9 is B, or 4. Okay, I'm good. Did you get that when you were trying to do this on your own? I hope so, because this is an important step. Otherwise, the other steps kind of are not going to work. Okay, again, you can say R is 9 and Q is negative 5. As long as the last step is the same, the middle steps can be a little bit different, but okay. So step 3, you take your ax squared plus bx plus c, and that middle term, that bx, you break it up as plus rx plus qx. Okay, so what that means in practice, you get x squared plus 4x minus 45. I made the 4x squared term red because that's the one we're going to change, okay? So that's why I made it red. And you replace it with r was negative 5, so rx is going to be negative 5x. Q was 9, so qx is going to be plus 9x minus 45. You're doing a little deconstruction here, okay? Because that's what factoring is. You're breaking things up into factors. So what we're really doing, if you paid attention to this, I don't know how well your abstract thinking is, but if you paid attention to this, what we're really doing is just we're doing FOIL in reverse. So we're multiplying in reverse. but you were doing a little deconstruction. So that's why we're kind of taking something simpler and making it more complex because we're breaking up into its parts. Okay, so x squared plus 4x minus 45 becomes x squared minus 5x plus 9x minus 45. Okay, so far so good. So step 4, first I'm going to write out my result here, and then remember what I said, you're going to consider two terms at a time. So x squared minus 5x, I'm going to consider that as one group, and then plus 9x minus 45, I'm going to consider that as another group. X squared minus 5x, the common factor is x, right? X squared divided by x is x. X squared divided minus 5x divided by x is negative 5. So x minus 5 is inside the parentheses. 9x minus 45, the common factor is 9. 9x divided by 9 is not x. Negative 45 divided by 9 is negative 5. So when you distribute, you want to be able to get these two terms as a result. All right, so what are you looking for in this step? You're looking for whatever is inside the parentheses has to be the same. That's what you're looking for. Okay, so far these problems are the easy or medium difficulty ones. Whatever is inside the parentheses was kind of organically the same. So what we're looking for is whatever's inside the parentheses the same. Let's say you didn't do that. Let's say you actually wrote x squared plus 9x minus 5x minus 45. So on this step, you reversed what the R and the Q values are. Okay, so I'm going to do this for these examples just to show you what would happen. You'd still consider two terms at a time. X squared plus 9x have a common factor of x. Minus 5x and negative 45, I'm going to factor out because they're both negative and negative 5. So get negative 5. And then remember, when you factor out a negative number, the signs inside change. So negative 5x divided by negative 5 is x. Negative 45 divided by negative 5 is positive 9. What you get here is that you get this x plus 9 in the parentheses. So binomials in the parentheses are identical. Actually, both of these will lead you to the right answer as long as whatever you have inside the parentheses is identical to each other. So not between the two problems, but within one problem. So x minus 5 equals x minus 5, x plus 9 equals x plus 9. Your answer is going to be the same. All right, so I'm going to proceed. Step 5, let's say we went with the left answer here. You got x times x minus 5 plus 9 times x minus 5. Remember how we factored x minus 5 gets written in parentheses together in green, and then what you're left with is x plus 9. That goes in the second set of parentheses, and you're done undoing FOIL. So that's your factoring, x minus 5 times x plus 9. But if you followed the right way to solve the problem, not the way to solve a problem that's on the right side, that's what I mean, not right as in correct, but as on the right side, you would get, okay, so x plus 9 is in the parentheses, so x plus 9 gets factored out, and then you get x minus 5 left in orange here. Well, actually, we know that multiplication is commutative, meaning that 5 times 10 is the same as 10 times 5. So x minus 5 times x plus 9 is the same as x plus 9 times x minus 5, okay? So whichever way you went, you really got the same answer, and either one is fine. So step 6, you either get x squared plus 4x minus 45 equals x minus 5 times x plus 9, or the way we got on the left side, or you got x squared plus 4x minus 45 equals x plus 9 times x plus minus 5. Either one is fine, okay? So the last step is we're going to check if we factored correctly. I'm going to pick one of these answers to check. I'm not going to torture you with both. So let's pick x plus 9 times x minus 5. How do you check? Factoring is dividing. How do you check that you factored correctly? You multiply. Okay, so we're going to multiply x plus 9 times x minus 5. How do you multiply two binomials? You do FOIL. First, outer, inner, last. Okay, so first x times x, outer x times negative 5. Inner 9 times x, last 9 times negative 5. So you get x squared minus 5x plus 9x minus 45. Or x squared plus 4x minus 45, which was what we were trying to show, right? Your factoring is correct. Okay, but this is the answer. This is just the checking your answer, okay? This is the answer. This is the important part. All right, we'll do two more of the same type. I'm messing with the signs here a little bit. First we saw plus, then we saw minus plus. Now we're seeing plus minus. We're kind of going to go through all the options. Okay.